All right, welcome to the final Algebra 2 review stream. Just a disclaimer, this stream is not made to just watch and then you're ready for the final. This is what I would say in class. I'm putting it into a YouTube video and making it go, making one big video. So this video, how you should watch it is as you watch it before you start studying or as you're studying, see and you look at the questions, you're like, oh, I don't really remember that question, and you go and practice that. This is not enough information to be mastering it. This is for information to see, oh, I should learn this, or oh, I forgot that. Let me check that out. With that in mind, let's start with the first one. I'm going to start at the chapter 4. I'm using the worksheet I handed out to everybody. So I'm using the worksheet. Chapter 4, I'm going to start with number 12. So this is chapter 4. Number 12, that is log base 5, 625, that to the x power. Now the rule logs first tells me that I can move this x into the front of this. So I'm going to write it as x times log base 5 times 625 or 625. Then I have to be a smart student and say, 625 over here, this must be some power of 5. And if you use your calculator and guess and check, you would figure out that log 5, that this is 5 to the 4th power. Well, this is to the 4th power, so I can move it in front again. So now I have 4x times log 5, base 5, 5. When the base and the number on the inside is the same, you could cancel it out. So your answer for this one should be 4x. And I'm just checking on the worksheet itself to see if that's true. Number 12, 4x, yep. Let's do number 13. Number 13, that is going to be log 4 to the power of log base 2, 8x. All right, so this is weird because log is on the top. Let me just kind of zoom in to make it a little easier to see. So log base 2, 4, log base 2, 8x. So what can we do? Well, I could change 4 into 2 to the 2nd power log base 2, 8x. So if I do that, that allows me to cancel out this here and this here. It allows me to cancel out the base 2, not this 2, the one I just made, log 2. It lets me cancel this, and this 8x is going to take its place. So that means it's going to be 8x to the 2nd power, the whole thing to the 2nd power, and your final answer should be 64x squared. So that should work out just fine. Let's go to number, let's condense something. So let's do number 18. ln 4xy squared minus 2 ln x squared y. So there's a lot of things, so let's see if we can condense it as best as possible. First off, I know the minus sign when it comes to logs can change the whole thing into one division. But before I even do that, I have a 2 in front of my ln. So I'm going to take this 2 and bring it up to the exponent. So ln 4xy squared minus ln x squared y all to the 2nd power. Let me distribute this to power. So this is going to be, again, ln 4xy squared minus ln x to the 4th, y to the 2nd. From there, I'm going to now change it into 1 ln, or 1 log. That's going to be 4xy to the second on top divided by x to the fourth, y to the second. Now, if you remember your exponent rules, you could cross out the y's here, because this is y second, 2 minus 2 is 0. This is x to the first minus x to the fourth. So that's going to give me ln 4 over x to the third. And I'm done with that question right there. We can do number 20. Let's do number 20. 4 to the 2x plus 4 equals 16 to the 3x minus 6. Now, in order to do this one, I want to change them so they're the same base. So in order to change them to the same base, I need to see if something is in common. So here, I could change 16, so 2x plus 4, into 4 squared, 3x minus 6. So now I could distribute the 2. So 4, 2x plus 4 equals 4, 6x minus 12. With that in mind, we're going to then, these two 4s are exactly the same. Because they're exactly the same, we could cross them out. 2x plus 4 equals 6x minus 12. I'm going to do plus 12 here. This is just a multi-step problem you learn in Algebra 1. Minus 2x here, minus 2x here. This is 16 equals 4x. This is going to give me x equals 4. And I just want to check if that is the correct answer. Yep, that's correct. Okay, so x equals 4. Let me do number 22. So it's pretty easy when you have two exponent or two bases are the same, but something like number 22 might not be straightforward. Because in 22 you have a log only on one side. So let's do that. This is still chapter 4. So we're going to do log to the base of 2, x squared plus 2x equals 3. So let's see. I want to get rid of this log first. So the only way I know how to get rid of this log is putting a base 2 underneath it. If I do it to one side, I have to do it to the other. So that crosses that out. So this just becomes x squared plus 2x, while this becomes 2 to the third power. X squared plus 2x equals 8. So I got to subtract 8 on both sides. X squared plus 2x minus 8 equals 0. And what you want to do is now you have to factor out, and this is one of these old things from Algebra 1, what are factors of negative 8 that add to positive 2? Well, that's going to be negative 2 and 4. So I'm going to do x minus 2, x plus 4 equals 0. Split these in half. X plus 4 equals 0, minus 4, x equals negative 4. X minus 2 equals 0, plus 2, x equals 2. So that factoring should not be too new to you. That is from like Algebra 1, and I think we did that also in the beginning of the year. For chapter 4, I would say that's it in terms of things I could expect you to know. Oh, let's do domain and range real quick. So let's do number 15. Number 15, we're going to do domain and range. So that is log base 3, x plus 2 minus 2. So the domain is only numbers we could put in here are 0 and bigger. So because I could put in any number here, 0 and bigger, the smallest number I could put into x is negative 2. So x has to be greater than or equal to -2. Because there's no number I could put here that makes it negative. If it makes it negative, it's impossible. So -2 is the smallest number I could put. In terms of range, it's always going to be all reals. So you never really think about that one. So the domain has to be the opposite of this number. So if this is +2, it becomes -2. And the range is always all reals for this. Anyone who's with me right now, do you have any questions or you want me to do anything from chapter 4? I'll give about a minute to type in a response. If you want to type in, just like log into your Google account or your Kushner account should be able to type, allow you to type.
Wait, look at me. Hi, sorry, 1 second. This is me, guys, this is me, look. Oh, this is me.
Okay, whatever. All right, I don't see really any responses, so I'm going to move on to chapter 5. Chapter 5. With that in mind, let me just pull out chapter 5, the test, the one I gave you, the worksheet I gave you. Rational functions. So this one was an interesting one. I remember grading these. And some people did well, some people did not. So that's the best I can say about it. So why don't we skip to number... Oh, let's do number 3. So number 3, what's really important about number 3 is that you have a joint inversely or joint inversely, or I'm sorry, it's either varies inversely or varies jointly. So let's see for number 3. It says particularly z varies jointly. And when it varies jointly, it's going to be multiplying to a, x, and y. Our a is a consistent, or a constant, I'm sorry, a constant. So that should stay the same, no matter what x, y, and z we put in. So first they tell me, find z when x is 2 and y is 3. So let's first figure out what a is. So z equals a, and we need to test find z when x is 2 and y is 3. So that has to be 2 times 3. And then for this one, just give me a second, I gotta check what they expect as an answer for this one. Oh, they just asked what z is. Oh, that's pretty funny. All right. Oh, so first you have to use the numbers that are given in the question. So for number 3, we were given that z equals 15, a, that x equals 5, and y equals -3. So in order, we have to use the numbers that are given in question 3 to find the z afterwards. So first we're going to do 15 equals a, 5 times -3. Well, that's 15 equals -15a divided by -15 on both sides. That is going to be -1 equals a. So now we found -1 equals a. We're going to see what happens when we plugged it in. And this is based off the bold text. So z equals -1 times 2 times 3. So z should equal -6. That was a bit confusing, so I want to do number 4 also. So first we know z varies jointly. with x and y, so they're multiplied. And we're given that x is negative 2, y is negative 2, and z is negative 16. So negative 16 equals negative 4a, or positive 4a, I apologize. Negative 2 times negative 2 is a positive 4. Then we're going to divide by 4, divide by 4. Negative 4 equals a. So let's see what we're going to do up here. Negative 4 times 2 times 3 equals z. 2 times 3 is 6. 6 times negative 4 is negative 24. So z equals negative 24. So first you want to find what a is, and then use the a to find the next piece. If you remember from the test I gave you, I would break it up into pieces. Since on the final it's going to be a multiple choice, I'm probably just going to ask for this answer right here. So you just go right to the conclusion. So let's go now to number... let's go to number 11. That's a good one. So number 11 of chapter 5. We're going to do x squared plus 7x plus 12 all over x squared plus, minus 7x plus 12. So first we have to factor this out. So we have to factor out the top and the bottom. So on the top, you're going to do factors of 12. So things that multiply to 12 that add to 7. That happens to be 3 and 4. So that's going to be x plus 3, x plus 4. On the bottom, we have x squared minus 7x equal plus 12. So that's going to be x minus 3 and x minus 4. Now we got to look at the top and the bottom and see if there's anything to cancel. For this one in chapter B, number 11, nothing from the top and nothing in the bottom is exactly the same. So because this is plus 3 and plus 4, and this is negative 3 and negative 4, I cannot cancel anything. So for this one, it's not possible. Or not simpleable. Like, you cannot make it any more simple. On the worksheet that I gave you, it tells you not possible. But essentially saying you cannot simplify it. So what happens if you can simplify it? So let's do number 12. We have x squared plus 5x all over x squared plus 6x plus 5. So let's figure out the top. Because there's only two terms, we take out the greatest common factor, which is just x, and parentheses x plus 5. On the bottom, we have x squared plus 6x plus 5. So we have to take the factors of 5, that adds up to 6. That's going to be x plus 1 and x plus 5. Now with this one, x plus 5 and x plus 5 is both on top and bottom, so I can cross those out. So all I'm left with is x over x plus 1. Because this x plus 1 and x are not the same thing. Make sure you understand that. You cannot cancel x and x plus 1. So because of that, it's just x, and maybe I'll put this in parentheses to be clear. This is one number, like one term, x plus 1. Well, this is another term, just x. So you cannot reduce that anymore. Now that's the basics of reducing. Why don't we do an actual problem where we have to do some math? So let's do let's do a multiplying one, and then we'll do a adding or subtracting one. So let's do 14, because that seems a little bit harder. So that is going to be 2x to the third over 7x to the y, xy squared, divided by 6x to the y second over 14y to the third. This is still chapter 5. So first we're going to do is make this keep change flip. So this is going to stay the same. This is going to change to a multiplication. And this is going to flip. So this is 14y third over 6xy. So we're going to try to simplify as much as possible before we do any multiplication. So from here to here, I can see that 7 can be reduced to 1, and 14 can be reduced to 2. 2 can be reduced to 1, while 6 can be reduced to 3. I can't reduce any more, so I took care of the normal numbers, which is 2 over 3. Now let's see what I could do with the x's. There are 2 x's on top and 2 x's on bottom. So that's going to be x squared over x squared. While here, there's 3 y's on the top and 2 y's on the bottom. So y cubed, y squared. You have to remember the exponent rules. If you're dividing two bases with the same, or you're dividing two exponents with the same base, you subtract the opponents. So 2 minus 2 is 0. So that's going to cancel out. Y third divided by y second, that's 3 minus 2, that is going to be 1. So your final answer is 2 over 3, 2y over 3, because 2 to the 1 power and 2y is the same thing. So that's how you do a multiplication / division one. Same thing, the division is just that you have one extra step, you got to flip it first. But basically the same thing. Let's go to number let's do 17. Number 17 with the adding and subtracting. So let's see. 7 over 5x minus 4 over 3x. So in order to do this, we're going to try to first get common denominators. Just like adding normal fractions, you need a common denominator. So what is the greatest common factor between 3 and 5x? Happens to be nothing. So I'm forced to times this one by 3x over 3x. And I'm forced to times this one by 5x over 5x. So on top, I'm going to have 3 times 7x, or 3x times 7 is going to be 21x over 3x times 15x is 15x squared minus over here 4 times 5x is 20x over, this is also 15x squared. When you subtract fractions, you only subtract the numerators and the denominator stays the same. So since the denominator stays the same, I'll write that first, 15x squared. And on top, let's see, 21x minus 20x, that's going to be just x. Now, if you remember our exponent rules, we have x to the first divided by x to the second. So that's going to be x to the negative 1. That means it's going to stay in the basement. That is 1 over 15x to the 1 power. These gets canceled out, so it becomes 1 over 15 to the x. 15x. Number 17, let me just check the answer, and that is correct. For chapter 5, I'm trying to see if there's anything else I might have left out. Let's do 21. That's a really difficult one, and one that should look familiar. I think this was the exact one I used on your test way back. 3 plus x all over 2 plus 2x, and I know it's written just as 2x. I'm just going to write this over 1 to make it a little faster for us, equals 6x plus 1 over 4 minus x. Sorry for the little overlap right there. With that in mind, we're going to try our best, and let me just, that's fine. So we're going to try our best to first get all the common denominators the same. Actually, before we even do that, why don't we just get this side, the common denominators the same? Because after that, we could do some cross multiplication, but let's just get this side done with. So what is the common denominator between 2 and 1? Well, that's 2. Well, 2, you don't have to multiply anything, it's already there. But this one, you're going to multiply 2 over 2. So this is 3 plus x over 2 plus 2, it's going to be 4x equals 6x plus 1, 4 minus x. So let's take care of this. 2 and 2 is here, though we could add these two pieces together. So that is going to be 3 plus x, and 4x is 5x, all over 2 equals 6x plus 1, all over 4 minus x. Now we set up like this, we could do a cross multiplication and still solve for x. So why don't we do that now? 3 plus 5x times 4 minus x. So this is going to be a foiling problem. First is 12, outers is minus 3x, inner is plus 20x, and outside is negative 5x squared. Over here, we're going to get 2 times 6x, so that's going to be 12x plus 2. I'm going to rewrite this as best as I can. So I'm going to I usually put negative, or the x squares first. Negative 3 plus 20 is going to be plus 17x plus 12 equals 12x plus 2. Subtract 2 on both sides. And I'm going to subtract 12x on both sides, actually. Just so I could get this all by itself. Negative 5x squared plus, that is 5x plus 10 equals 0. Now this is a factoring problem, and if you don't remember how to factor with an a, the good news is, if we look at here, 5, 5, and 10, we have a common multiple. So I'm going to factor out a negative 5 in front, and that's going to make it x squared minus x minus 2 equals 0. So now this is a little bit easier. What factors of negative 2 is going to get you negative 1? Well, that is going to be x minus 2 and x plus 1 equals 0. So your two answers for this one is negative 1, because this would be negative 1. And this is going to be positive 2, because x has to be positive 2 here. So your two answers is negative 1, comma, positive 2. If you have any questions, I'm going to go on to chapter 7, I think it is. If you have any questions for chapter 5 or any requests, like you want me to do a problem from chapter 5, please ask now. Oh, we did do chapter 6. We're going to do chapter 6 next, by the way. If anyone has any questions for chapter 6, please ask now. Or chapter 5, please ask now. Okay, let's move on to chapter 6. So chapter 6, the combination and binomial theorem, and all these things. This is not too bad, actually. This should not be too bad. So let me just open up this one. Can someone tell me, did I give anyone chapter 6? Because chapter 6 is going to be on it. We did do chapter 6. Actually. No chapter 6? Chapter 7 I gave you? Okay, so let's go to chapter 7. So this is the sequence and series thing. So there was a couple of formulas that I'll put up here. So scribble this out, chapter 7. So there's a couple of formulas. So let me write those up here first to make our job a little easier. Because once you know the formula, it's really easy. First is arithmetic. If you remember what arithmetic sequences is. That's when they keep adding. For example, 4, comma, 9, comma, 14, comma, 19, dot, 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 dot. So each time I'm adding 5. Each time I'm adding 5. Each time I'm adding 5. So how do we get the rule from this thing, or the series? Our equation for arithmetic is an equals a1. Is 6 on the final? I'm going to open up my final right now. I'm pretty sure 6 is not on the final. So I'm just going to check one more time in case if I did accidentally put it on the final and make some corrections there. This is number 2. Series. You have your angles, matrices. I'm just scrolling up. Did I forget to put in? Oh, yeah. Chapter 6 is in the final. I will be printing that and giving that out tomorrow. I'll do that at the end of the video because we don't have any worksheets for it. But chapter 6 is on the final, and I'll post that right after this video. After I finish this live stream, I will post the chapter test for that thing and a little bit of notes for that. We have 1, 2, 3, 4, 5, 6, 7, 8 questions on it. So I want to make sure you get those. These should be pretty easy. Some reason I put chapter 7 in front of chapter 6 though, so that's why I got confused. So let's go chapter 7, because on your final, it is chapter 7 before chapter 6. So let's do that. Write an equation for this term. Okay. Chapter 6 is NCR, yes. NCR, that's choose. The other one is like, if you have 5 cards and you wanted 2 hearts and 2 non-hearts, what's the chances? I'll go over that a little later. Chapter 6, again, I will post that right after this live stream. That is my fault. But we did do chapter 7 before chapter 6, so I'm going to keep chronological order to how we did it. So let's continue. Let me just pull up the formula because I just had to check my final. It is A1 plus N minus 1D. And just to remind you what the labels are, A1 is the starting or the first term, and D is the difference or the rate, like what is changing by, and N is just what number step you are. So N is a number step. So first, let's find the equation of this, 4, 9, 14, 19. Let's just use this one since I already made it. So my AN is going to be, my first term here is 4. So 4 plus N minus 1 times D. D in this case is going up by 5 each time, so times 5. Jacob, let me just check that question. Do you need 23 for chapter 5? I do not believe so. I do not believe so. I can check that real quick. No, the last one I did, which was 21. 21 is the hardest one that I would give you. So you do not need to be sure of 22. It's the same type of problem, but that's harder than what I would give you normally. So I'm not going to ask you to do that one. So 21 is the one I would focus on. So let's continue. AN equals 4 plus N minus 1 to the 5th. Going to distribute 5 to both of these. an equals 4 plus 5n minus 5. I could combine these terms. An equals 5n minus 1. So that's my equation. If I were to ask a question like, what is an on the 10th step? So if I had to go to the pattern 10 times, all I could do is plug in 10 here to get it quickly. An equals 5 times 10 minus 1. So an equals 50 minus 1. An is 49. And if you were to repeat this pattern up to the 10th term, it should be 49. So that's the usefulness of it. So let's look at the actual testing I gave you. So we have that, and then I can do some problems from there. Let's see, chapter tests. Part B. Let's do number 1. Write the first 6 terms in the sequence. Now the first 6 terms, you always use steps 1 through 6. So for number 1, chapter 7. Number 1, chapter 7. What we're going to do is an equals n minus 4. All I'm going to plug in is 1, 2, 3, 4, 5, 6 into n. So 1 minus 4 is going to be negative 3. 2 minus 4 is negative 2, negative 1, 0, 1, 2. It's pretty straightforward, the first 6 terms. You just plug in 1 through 6, and you give me all 6 terms. Now, find the sum. Let's see, look at number 3 real quickly. That's what I was talking about before. Number 3, find the series using the notation. So this is negative 5, comma 5, comma 15, comma 25, dot, dot, dot. So first term is negative 5, so an equals negative 5 plus, or is it plus or minus? It is plus n minus 1 times d. Since you're going up by 10 each turn, is going to be 10. Distribute the 10. An equals negative 5 plus 10n minus 10. Minus those two together, negative 15 plus 10n equals an. You can also write it as 10n minus 15. Okay, both answers are acceptable. So that's number 3. Let's do number 4. How do we get the sum of the series? To quickly get the sum of the series, we're going to use this equation. S equals, and let me just write down this problem before I go on. This is I equals 1, 6. And I'm pretty sure you guys showed me before your calculators can do this. I just want to show how to do it quickly by hand if you want to do that. So you either could plug in 1 through 6 and then add all the pieces together, or you could use this formula. The sum at n is equal to n times a1 plus an over 2. A1 being your first term, an being your last term, n being the how many terms you used, and divided by 2 is just the average. So you just want the average of it times n. So let's first find your first term. So that's when a1, so that's when 4 times 1, that's going to be 4. Let's find the last term, which since we're going up to 6, we're going to go to 6, so a of 6. 6 times 4 is 6, 12, 24. So it's going to be n, how many steps I did was 6. 4 plus 24 over 2. 4 plus 24 is 28 over 2. 28 over 2 is going to be 6 times 14. And then 6 times 14 should be, so sum of to 6 is going to be 60 plus 24, 84. So you can use that equation. Also, there's somewhere in the calculator. I personally don't remember how to do it, but if you bring in the calculator, I'll make sure I know by tomorrow. So that's chapter 2. All right, that's chapter 7. Let's see what else we got. Oh, geometric sequences. So why don't we look at test number, or question number, let's see, whether the sequence is arithmetic, number 6. No. 7th, no. Sum, no, I don't really care for that right now. Okay, how can we tell it's geometric? So in order to tell if it's geometric, we gotta see if it's multiplying each step. So for example, geometric, multiplying to each step. So like 2, 8, 32, 128, ... So each step is times 4. Each step is times 4. Each step is times 4. So that's a geometric sequence. To make the equation a geometric sequence is simply this formula. AN equals A1 times Rn minus 1. And R represents what you're multiplying by. So for this sequence particularly, AN equals 2 times 4n minus 1. 2 is your first point, and 4 is the one you're skipping up by. So let's look at a quick question from this. So let's look at chapter 7. Let's do number... Let's do number 11. Yeah, let's do number 11. Chapter 7. So let's do number 11. This is find the sum of this equation. I equals 1, 5, 3, 2/3 I. So we're going to find the first term and the last term. And to find the sum of this equation is not too bad. The equation for that is Sn equals A1, 1 minus R to the n power over 1 minus R. So how can we identify what R is and what n is? Well, we know A from the equation here, A1 times R. So we're going to figure out that A1 is going to be 3. So Sn equals 3. And R is going to be 2/3. So 1 minus 2/3 to the n power. Since I'm going up to the fifth, it's going to be to the fifth power over 1 minus 2/3. So that's S of n equals 3. 1 minus 2/3 to the fifth power is going to be 3 to the fifth power is 243 over or under 2 to the fifth power should be 32. Over 1/3, because 1 minus 2/3, it's 1/3. 1 minus this is going to be 3 times, this is going to be 211 over 243 divided by 1/3. If you remember when we divide by fractions, it's like multiplying by its reciprocal. So I'm going to write this as 211 over 243 times 3 over 1. You could type this as a calculator straight, but if you're just doing it by hand, I probably would have reduced 243 by 3. So that's 81. So this is 1, and this is 81. And I also know this 3 over 1 is going to be reduced, so I could reduce this also again. This is going to be 27, and this is going to be 1. So what I'm left with is 211 over 27. And 211 over 27 is going to be 7.81. So that's a lot of work. I'm going to promise you that it's not going to be this complicated. Or I'm not going to give you a fraction, so that's going to be less annoying on the final. But that's basically how you do it. You just plug it into the formula, do it. Also, you could be smart, bring your calculator, learn how to use that on your calculator, get the sum of a geometric sequence. If you need to Google that, you could Google that. But we're not done with chapter 7 yet. We do have one more thing, the infinite series. And we want to know if the infinite series are going to anywhere particularly. So why don't we take a problem from the worksheet, which I think was numbers, let me check. Chapter tests, please open up. Let's do number 13. So number 13. So what we're given is I equals 1 to the infinite power. So you know you're in a situation like this when you see the infinite power. 2, 3 over 4, I minus 1, or what do you use? They use K for some reason, but whatever, I'll use I minus 1. Okay, so the first thing you have to see is R less than 1. Now 3/4 is 100% less than 1. So that means we can find it if, so there is for a fact one that's infinite. So this one is super easy to find though. The sum equals A1 over 1 minus R. So this is super easy. And for infinite series, I'm pretty sure your calculator cannot do that, so you do at least have to remember this one. Maybe your calculator can, but I do not recall if it can. Your T84s or more. So if it doesn't do that, let's do S equals, A1 is always the first term here, so that's 2 over 1 minus 3/4. That is going to be 2 over 1 minus 3/4 is 1/4. And if you did that in your calculator, or you just know that this is going to be the same thing as 2 times 4, that's going to be 8 in total. So a much more simpler problem, those infinite geometric ones, if you know how to set it up. If you don't know how to set it up, your calculator can't help you in this situation. That wraps up the basics of chapter 7. I want to check, I just got to check carefully now that we have chapter 8 in this. There's no way we have chapter 8. So why don't we go to chapter 9? Trigonometry. Lovely, lovely trigonometry. Everyone's favorite. The good thing about trigonometry is not as hard as logs, but it could get that close. So for chapter 9, we're going to do, let's go right to number 3. So if you have this, and this one could be done by hand, but since we always have a calculator, might as well just use a calculator. So this is 60 degrees. This is 6. Let's find x and let's find y. So to find x, we notice that this is the opposite and an adjacent. Which one uses opposite adjacent? We use SOHCAHTOA. Opposite over adjacent, uses that. So that means tan of 60 degrees equals opposite, which is 6, over adjacent, which is x. Now, if x is on the bottom, this is always going to turn out the same. You're going to times x here, and you're going to divide tan 60 here, divide tan 60 here. So that's going to be x equals 6 divided by tan 60. Let me get my calculator out. And if you're not sure if your calculator's in radians or degrees, you can always bring it in tomorrow or before the final. Remember to bring your own calculator so school will not give you one. You're so out of luck if you don't bring a calculator. Like, you might as well just buy one on Amazon and get a first day delivery if you forget it. I don't know any places around by that sells calculators, but you gotta get one right away if you don't have one, or if you can't borrow one for the test. Remember, everyone's taking the same math or taking the math test at the same time. While my computer loads up the calculator, let me just set up the next one. So this is opposite and hypotenuse. So that's going to be sine, because S-O-H, is going to be SOHCAHTOA. Are we going to get word, okay, are we going to get word problems to like 12? 12 like in chapter 9? Is that what you're asking? And I have to decline for the duos, Jacob, but thank you. No, from 7. Let me just look at it real quick. Let me look at my actual final so I can answer that very confidently. Let's see. Write equation for a sequence for the nth term. Come on. Write an equation for the nth term. Find the value of the 10th term. Use the geometric sequence. Find the sum of the first 8 terms. Sum of this. Sum of that, sum of this. No word problems, Jacob. I'm sorry, so I got to decline the duos. I'm working right now. So this is sine of 60 degrees equals, I gotcha. Sine of 60 degrees is going to be 6 over y, so opposite over hypotenuse, 6 over y. So we're going to times y on both sides. Times y on both sides is a story we've seen before, divided by sine 60, divided by sine 60. So it's going to be y equals 6 over sine 60 degrees. Just to quickly look at the calculator, now it's loaded up. 6 divided by tan of 60. Let me just check this in degrees. Yeah. Is 3.46. This is for here. X is going to be 3.46. After you find x, you can do something else. Like you could use Pythagorean theorem if you want to find y in this situation. But since I already set this up, I'm going to continue. Sine 60, so I'm going to do the same thing. 6 divided by sine 60 this time. That's going to give me 6.92. Remember, most of your questions are multiple choice. With that in mind, that means that 2 decimal points. There is some open-ended question, and there is an open-ended question with trigonometry. So you got to make sure you do 2 decimal points. I'll put down the final also. So that's number 3. Let's see what else we can do. Bicycles, wait. I'm about to read a problem on the final. That would have been a mistake. Let's see what else we got. Oh, convert degrees to radians and radians to degrees. So this is pretty easy. If you don't remember, just think of it like this. Let's say you start with degrees, like 200 degrees. You want to make it so pi is on top of the fraction. So I'm going to do pi over 180. If you start with radians, like 3 pi over 2, you want to make it so pi gets canceled out. So it's 180 over pi. So first let's do this. This is degrees to radians. So 200 degrees times pi over 180. You simply simplify the top and the bottom. This is a 10, this is a 9. So your answer is 10 pi over 9. Over here, this is radians to degrees. So we're going to simplify as best as we can. 2 becomes 1, well, this becomes 90. And 3 times 90 is going to be, and these pi's get canceled out, so 3 times 90 is going to be 270 degrees. So changing degrees to radians and radians to degrees makes it a lot easier. Use the given point of the terminal side, the position. That's if you want to do the trig stuff. You will have a calculator for the whole thing, so I wouldn't sweat anything that says not a calculator, because you literally just type in for like number 12 and number 11. You just type in sine of negative 120 and tangent of 225. Like you just type it in. There's nothing special about it. Do I ask you to solve ABC? That's statistics. No, next thing is matrix. Okay. Wait. Here it is. So we did that. We did that. Oh, what happened? What if we want to find an angle? So, do they have that in the worksheet actually? Before I make this triangle. Okay, so what if we want to find an angle? So I'll make one up. So this is 8, and let's say this is 12. Okay, so that's 8, that's 12, and this is theta. So we want to find theta. How do we do that? First, I gotta recognize what sign of the trigonometry I'm using. This is opposite, this is hypotenuse, so that is going to be a sine. Sine of 8, sine of theta equals 8 opposite over hypotenuse, which is 12. So how do I get the sine away from the theta? Well, I got to use -1 sine. So that's theta equals sine inverse of 8 over 12. And this one is really easy because you could just type that into your calculator. I'm going to do that right now. Second sine 8 divided by 12, close parenthesis, enter, 41.81. Theta equals 41.81. So that is 48.81. Let's see what else we got. What else is on that? I'm looking at both my final and the paper I handed out to see what I ask you. Just to make sure I don't forget anything. Like I forgot chapter 6. Find that side, change radian degrees, degrees to radians. All right, we're all good for that. So let's see what else we got. One thing I definitely forgot to mention is chapter 6. I'm going to end the stream now because it's already an hour. So thank you for everyone who's watching and who has watched and watching this in the future. Ending the stream now. We're going to do chapter 6. I'm going to post that today, like right after this video live stream is over. And I'm going to post the practice test with chapter 6. I'm going to tell you what numbers I expect you to understand. And we're going to practice that out because I did neglect that to you guys. Chapter 6 is definitely on the test and it's got a couple of questions. So I want to make sure you do those properly. I might either make a separate video or maybe do a second live stream. I don't know there. Until then, do the basic things like the video, smash that subscribe button, yada, yada. I hope this helped you out. I hope this helps you out. Just understand what you need to know and what you don't need to know. Again, chapter 6, I'll do either a separate video or I'll do a separate live stream for it. Otherwise, thank you guys for everything. Good luck on your final. And that's it. I'm trying to use inverse sine on that one. No problem, Rachel. Oh, Raquel. Thank you. No problem.